video for section 6.6, finding surface area, we're going to find the area of the surface generated when a curve is revolved around the y-axis. So the example that we're going to do here is the curve y equals 4x minus 1, and we're going to do it over the given interval from 1 to 4. So remember, the directions explicitly state that we should revolve this around the y-axis, which means that when we find our surface area, we're going to be integrating with respect to y. And so remember that the formula goes from c to d when we integrate, 2 pi times x, because we're integrating with respect to y, times the square root of 1 plus dx over dy quantity squared. And again, integrate with respect to y. So the first thing that we need to do here is we need to find what we might call g of y. So in other words, take our original equation and solve it for x as opposed to y. So remember that we have y equals 4x minus 1. In order to isolate the x, I'm going to have to add 1, and I'm going to have to divide by 4. So I have my equation x in terms of y. The other thing that I need to do is figure out the interval in terms of y. And that'll help me determine my c and my d, the limits of integration. So remember, I started with 1 and 4, and those are in terms of x. So in order to find the corresponding y value, I need to use the given relationship between x and y, which is that y should always equal 4x minus 1. So in the first value, I'm going to get 3. And my second value is going to be 15. So my new interval in terms of the y-axis is going to be 3 to 15, and those are going to be my limits of integration. All right, remember in the formula, we need limits of integration, check, have that. We need our equation for x in terms of y, we also have that. But we are going to need to find dx over dy, or in other words, the derivative of the function written in terms of y, and then we'll have to square it. So that's next. So we need our dx, dy. So we're going to find dx, dy by finding the derivative of our function y plus 1 over 4. Remember, the 1/4 is a constant multiple. It can be set aside while we take the derivative of y plus 1. The derivative of y is 1. The derivative of 1 is 0. So in this case, for dx dy, we actually get a constant of 1/4, and we need to square that. So if we square 1/4, we get 1/16. All right, now we are ready to write our equation for surface area. So we're going to integrate from 3 to 15, 2 pi times y plus 1 over 4 times the square root of 1 plus 1/16, and integrate all of that with respect to y. All right, so that's the setup. Now we just need to actually do the integration and then use the fundamental theorem of calculus to evaluate it. So that should go pretty quickly. So once again, let me just get that integral in front of me here. We're dealing with a lot of constants here, a lot of constant multiples that we can pull outside of our integral. First of all, 2 pi times 4 can be simplified to pi over 2. So that can be folded out front. In addition, this is a constant, which I may want to rewrite a little bit differently. If I get a common denominator here, I'll get 17/16 square rooted. And so once again, I can pull that out. So I've got pi over 2, and I've got the square root of 17 over 4, since the 16 on the bottom is a perfect square. And what you can see is that all we have left to integrate is just y plus 1, which is super easy. So my surface area can be written as the square root of 17 pi over 8 times y squared over 2 plus y evaluated from 3 to 15. Let's plug 15 in. Square root of 17 pi over 8 doesn't change. 15 squared is 225 over 2 plus 15. And from that I'm going to subtract 3 squared, which is 9 over 2 plus 3. I have a little bit of fraction work to do. So if I get a common denominator here of 2, I'll have 225 plus 30. So that'll be 255 over 2. And then from that, I'm going to subtract over here, getting a common denominator of 2. So that'll be 15 over 2. And that gives me, when I subtract 255 minus 15, that's 240 over 2. 240 over 2 is 120. And the 120 and the 8 can be simplified to 15. So 120 over 8 is 15. So we get 15 square root of 17 pi. Now all three of those things are being multiplied, and the order in which they're written shouldn't matter. So this is probably the most preferred, where you've got the whole number, the pi, and a radical, although it doesn't really matter. So there's an example of finding the area of a surface when we're revolving a curve around a y-axis.